Hello, everybody. Welcome back to week 2. This is ET120 engineering problem solving, and we're going to continue on with sketching. And how do you like my shirt? Got your back. All right. So, a few problems with last week. Some of us sketched but used a straight edge. So that's not the sketching we want. And you cannot. It is not fair. It's not fair to the rest of us who are sketching by hand to do a light line, right, and then sketch over it like that. No, that's not fair, right? So sketching is supposed to be just finding two spots and then going between them. And if you're trying to draw parallel lines, then it is okay to measure here and here, right? I'll change this a little bit. Measure here and here. That's all right. You could take your scale and do that measurement. That's legal. But then you have to hand sketch. So hand sketch between trying to keep these parallel. So it is okay to measure the distance between lines. It is okay to give yourself a starting and an end point. But then when you sketch by hand, right? Fill it in. When we do instrument drawing, then we will use instruments, right? We'll use these, and we'll use a T-square. We're not using those yet. So I'm going to give you another sketching exercise just so everyone understands what I'm talking about when I say sketch. And we need to get good at it, not just straight line sketching. That's what we're practicing now, but also pictorial style sketching or three-dimensional style sketching. So we're going to work on that also. I also want to cover just basic measurement and kind of how the scales work. So I had you use it a little bit last exercise to lay things out. But I want to go through a little more detail, like the whole function of this thing. Not the whole function, but more functions. And we'll use these quite a bit to lay out our drawings when we're doing the manual side of drawing. So I want to talk about your next exercise. It's just another line exercise. It will not be in depth like your last one was 6 boxes. I'm only going to make you do 3 boxes. So you got to pause it and take some notes so you don't end up doing way more than you need to do. So I'm going to switch cameras. And we can look at the exercise. So this is the one you just did, right? Zoom in on that a little bit. And that went pretty well. You all laid it out actually very nicely, so good job with that. These kind of dimensions are telling you how far apart the lines are, right? And notice we like these parallelism. Now, when you put your name on this title block, and this information across the bottom, notice that it's much smaller. And in the front of the book, it actually shows you the text height, right? So it says that it's 0.12. So if you don't know your fractional equivalencies, you don't necessarily have to if you have an engineering scale, because the engineering scale will just give you 0.12. So if you want a 1-to-1 or an actual full inch, that's called the 10 scale. Okay, so then 0.12 would be right there. There's 0.1, that little piece, and then 0.12 is just past it. If you know your fractional equivalencies, then you know that 0.125 is 1/8 of an inch, because if you take 1 and divide by 8, that would be 1/8 of an inch. So this is a true 0.125 right here, 1/8 of an inch. So that's as big as your text is supposed to be in this title block. Some of you got pretty big on the title block with your text. Know that there are controls to every aspect of drawing, and those are the controls we really want to master, right? So when you're putting your name in, and this size, that's back here, it's called out, right? It's a clear, distinct size. It says 0.38. Doesn't necessarily, oh yeah, it does, it says right there, 0.38. So for Form 2, and that's what we're using. All right, so get those sizes down correctly. A big part of this class, I'm going to come back at you a little bit here. an enormous part of this class is gaining this attention to detail that we need to have to work within the engineering field. So when you're laying these drawings out, you need to have as much attention to detail as possible. If you know in a measurement, then let's put that measurement in and make it the right size. Let's see if we can collect information from a lecture like this or the book and determine exactly how to do this exercise. That's the kind of attention to detail we're going to need when we get out there to work. I get that it's the first term, I get that it's the first year, but our tools are things like calculators, things like being able to read and master and use a scale, building our ability to have attention to detail. That's what we're working on. So that's what you need to try to work on. All right, back to the exercise. All right, so you did this one, and they really did look good. Even if you used the straight edge, they looked really good. But now you're going to do this one. All right, no freaking out. You're not going to do these three. You're going to do this one, and this one. Notice there's some different line styles. So we're going to have to start to learn about these line styles, and what you're going to do is just try to emulate what you see. So when you do this dash line, it looks like there's about, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, maybe 14 dashes. I'm going to look for the same kind of approximate dash numbers. So again, just building attention to detail. Sketch, no straight edges. I know these are produced by a computer. I'm asking you to sketch it, not use any instruments. All right, so let's talk about the layout. The layout is the same as this one. You set up your 7 by 10, I think it was. You set up your title block area, and then you're going to divide it into 2 equal spaces above and below, and then 3 equal spaces this way. So again, just doing some math to set up just these 3 boxes. All this you can leave blank. You don't have to do it, do not have to do it, do not have to do it. That would take you a very long time. Just these top 3, okay? Notice that the dimensions have changed. These dimensions are in millimeters. I didn't make you get a millimeter scale, but we can convert. In other words, this one's easy. 8 equal spaces, just take your distance here to here, just like you did up on that other exercise, the one that's up there, and turn it into 8 equal spaces and you'll have it. This one, though, it says, hey, again, I would start in the middle. I'd find that middle spot, and then I'd go halfway, 6 1/4, 6.25 this way, 6.25 this way, and that would set up your first set of lines, okay? But how do we get 12.5 into inches? A little conversion. We have calculators, and we should know, if we don't, we could look it up. We should know that conversion. But if I know I have 12.5 millimeters, that's a number. All numbers I can put over 1, right? I can convert from millimeters to inches as long as I know the conversion. So once you look it up, then you'll have it. I remember always that 2.54 centimeters are per inch equals 1 inch. That's the one that I just have memorized. So then, of course, that tells me that 25.4 millimeters equals 1 inch. About ready to lose this pencil. Keeps breaking on me. Oh yeah, we're gonna switch. All right, equals 1 inch, right? So that's the one I'm gonna use. Again, if you don't know it, look it up, right? It's in your book, and it's also online. You can look up any kind of conversion. We write them like this, but then when I use them to convert the 12.55 millimeters, I'm going to multiply by the conversion factor that I want, and I'm going to think about this unit crossing out. So I want the millimeters down below, 25.4 millimeters over 1 inch, or 1 inch over 25.44. You can write this conversion either way. Either way, that's legal. I wrote it this way so the millimeters will cross out. I know that maneuver from all the math classes that I've taken. And that leaves me with inches. So 12.54 or 12.5 gives me 0.49. 0.49 inches. Pretty much what? Pretty much a ½ inch. So if we're using a architect scale, and I know it's architect because it says architect on there, then I always want to work with the 16 scale. That's full inches broken into 16ths. So 1/16, 2/16, 3/16, 4/16, right? That's why they call it a 16 scale. But this is the full 1 inch, and then this would be a ½ inch. So for this number, 0.49, that's approximately a ½ inch, right? And for manual drawing, that's as close as we're going to get, really. But it's from there to the half mark, right? That's a ½ inch right there. Now, if I use the engineering scale, and I know it's an engineering scale because it says engineer's scale on it, right? I look for the 10 scale because that means every inch is broke into tenths. So 1, 2, 3, 4, 5 tenths. So 0.49, this is 0.5. It's literally just super close to this. So again, if I use this scale, it would be from here to here, would be 0.49. Same distance. So I should be able to put these two together and see that a ½ inch equals a ½ inch, and it does. Okay? So when you're using these scales for now, we want to use the 16 scale on architect, if you have that, or the 10 scale on engineer scale, and you'll be working in full inches. Okay? So in the beginning, like right now, we want to work in full inches. We're drawing things their exact size. So when you do that exercise in the book, you're drawing it the exact size. We're using full inches. At some point, we'll start scaling things down and scaling things up, right? Not drawing them their real size. We have to do that when we draw big things to get it onto small pieces of paper. So, all right, I hope that helps. Let me switch to it one more time. And just look at that exercise. I think the layout's pretty simple. I think you'll be able to figure it out. This one's 8 equal spaces. This one, find that, and then go half and half, and that sets up. And then 12.5 is all of these, right? They're all 12.5 apart. Nice and perfect, sketched. All right, then this one, clearly you find the center. And these are 10 millimeters apart all the way around. So I would lightly sketch them in, and then I would erase pieces. That's how I do it. But it's completely up to you how you do it. But if you had some lightly sketched lines, right, going this way and this way, you get them all laid out like that. Best I can do without spending a lot of time measuring. Then I would want to clear this center area out, right? And then I'd start to erase to make these two go this way, these two go this way, right? This becomes this becomes this, yeah? Anyway, that's one way to do it, or you can just lightly measure and separate them out. But in the end, you're going to want to just sketch these, right? Give yourself some measurements and work through it. All right, fantastic. Sorry. Not a lot of, like when we do this in class, there's There's no lecturing class. The advantage is you usually work in this room with me here in the lab, and I can help you with the layout, I can help you with the hand sketching, and there's a little more back and forth. So as you're doing it, if you have questions, please don't hesitate to ask me. It's your education, and you want to make sure there's clarity, and you want to get all your points. So go into the grading area, check the grading out. There's comments. Please look at the comments. That feedback is critical for you so you don't continue to make mistakes. So I try to get everything graded over the weekend so you could look through your comments. You go to My Grades, and you look for those little comment pieces, and you click on them, and that'll tell you if you did a great job, nice job, or awesome job, or you missed something. Hey, make sure you're careful about this when you go to do lettering, right? You have nice guidelines, and you get your lettering the right height. So, all right, good luck, take care of yourself, and I will see you on Wednesday.